I want to stress a concept that is really important before we move on. What does it mean equivalent here when we say equivalent parallel resistance? Because obviously if we take this circuit and change it into this one, the circuits are not equivalent anymore. We even have a different number of components. How could they be equivalent? What the equivalent word means is that this network of components behave exactly the same way as this individual component from the point of view of the external circuit. So this, it's a little bit of a mouthful, but let me just explain with a very simple circuit. So if we have a battery generator connected, our usual battery generator, you could see this network of resistances as one big component. Now, the battery source, the voltage generator, doesn't know what it is connected to. The only thing it knows is that it applies a voltage across these components. So you have 0 volt here and V volts here. And as a result of that, there is a certain current I that is requested out of the voltage generator. From a point of view of the voltage generator, whether this component is made of n resistor or it's made of just one resistor, there's no difference as long as the required current is the same. There's no way this voltage source has a way to understand that there's only one resistor instead of 10. So this is what the equivalent word means. It's equivalent from the point of view of the rest of the circuit. Now, if you consider the overall circuit, obviously these two circuits are not equivalent anymore. Here we have n plus 1 components, including the battery source, the voltage generator, and in the other case we will only have 2 components, the voltage source and the parallel resistor. So this is a really important concept. The equivalent parallel and serial resistance is a very useful concept. Most of the time it's just used to simplify the mathematical calculation, because if you knew what is the equivalent value of this parallel resistor, it will be much easier for you to calculate the current given a voltage. Whereas if you don't know what is the equivalent parallel resistance, every time I change the voltage, to know what is the current I, you will have to calculate the current in each of the resistor, then sum it up all together, and then you can tell me what is the value of I. So that is one of the usage of the equivalent parallel and serial resistor. Other times you might actually calculate the value so that you can replace many components with a fewer number of components, but it's very important to stress that that is not a must. Doesn't make necessarily a circuit better than another. Each case is different.